The human body is a marvel of interconnected systems, with each part playing a crucial role in maintaining overall health. While we often think of the brain as the command center, dictating our thoughts, emotions, and behaviors, emerging research has shed light on another influential player, the gut. Indeed, the intricate link between the gut and the brain is a fascinating area of study that has significant implications for our physical and mental well-being. At first glance, the idea that the gut and brain are connected may seem puzzling. After all, the gut, comprised of the stomach, intestines, and other digestive organs, is primarily responsible for processing food and extracting nutrients, while the brain governs cognitive functions and behavior. However, recent scientific findings have revealed a complex network of communication between these two seemingly disparate organs, known as the gut-brain axis. One of the primary mechanisms through which the gut communicates with the brain is via the vagus nerve, a long nerve that extends from the brainstem to the abdomen. This bidirectional pathway allows signals to travel back and forth between the gut and the brain, influencing various physiological processes and behaviors. For example, when you experience feelings of stress or anxiety, the brain sends signals to the gut, leading to symptoms like butterflies in the stomach or digestive discomfort. Conversely, the gut is also home to a vast ecosystem of microorganisms known as the gut microbiota. These microbes play a crucial role in digestion, nutrient absorption, and immune function. However, research has shown that they also produce neurotransmitters and other signaling molecules that can directly impact brain function and behavior. The gut microbiota has been implicated in the regulation of mood, cognition, and even neurological conditions such as depression and anxiety. Furthermore, the gut is a major producer of various neurotransmitters and hormones that influence brain function. For instance, serotonin, often referred to as the feel-good neurotransmitter, is primarily synthesized in the gut and plays a key role in regulating mood and emotional well-being. Imbalances in serotonin levels have been linked to mood disorders such as depression and anxiety, highlighting the importance of gut health in mental health. The role of the gut-brain axis extends beyond just mood and emotions. Research has also implicated it in conditions such as irritable bowel syndrome, IBS, a gastrointestinal disorder characterized by abdominal pain, bloating, and changes in bowel habits. Studies have shown that individuals with IBS often experience alterations in brain structure and function, suggesting a bidirectional relationship between gut dysfunction and changes in brain activity. So, what can we do to support a healthy gut-brain axis and promote overall well-being? One key strategy is maintaining a balanced diet rich in fiber, fruits, vegetables, and probiotic-rich foods such as yogurt and fermented vegetables. These foods nourish the gut microbiota and support optimal digestive function. Additionally, managing stress through techniques such as mindfulness, meditation, and deep breathing exercises can help reduce the impact of stress on the gut and brain. The gut-brain connection represents a fascinating area of scientific inquiry with far-reaching implications for human health. By understanding and nurturing this intricate relationship, we can unlock new strategies for promoting physical and mental well-being. From the food we eat to the way we manage stress, every aspect of our lifestyle can influence the delicate balance between our gut and brain, ultimately shaping our overall health and happiness. Antibiotics are powerful medications designed to kill or inhibit the growth of bacteria, making them invaluable tools for treating bacterial infections. However, while antibiotics can be life-saving, they can also have unintended consequences on the delicate balance of the gut microbiota and the gut-brain axis. 1. Disruption of the gut microbiota. Antibiotics are nonspecific in their action, meaning they not only target harmful bacteria but also affect beneficial microbes in the gut. This indiscriminate killing of bacteria can lead to a significant disruption in the composition and diversity of the gut microbiota. Reduced diversity. Antibiotics can decrease the diversity of the gut microbiota, which is essential for maintaining a healthy balance of microbial species. A loss of diversity has been associated with various health problems, including gastrointestinal disorders and metabolic conditions. Overgrowth of pathogens. In the absence of competition from beneficial bacteria, opportunistic pathogens may proliferate, leading to conditions such as Clostridium difficile infection, CDI. CDI is a serious and potentially life-threatening infection that can cause severe diarrhea and colitis. Long-term effects. Studies suggest that the effects of antibiotics on the gut microbiota can persist long after the completion of treatment, potentially predisposing individuals to future health complications. 2. Impact on the gut-brain axis. The gut microbiota plays a crucial role in modulating the gut-brain axis, influencing various aspects of brain function and behavior. Disruption of the gut microbiota by antibiotics can therefore have implications for mental health and cognitive function. Mood and behavior. Alterations in the gut microbiota composition have been linked to changes in mood and behavior. Antibiotic-induced dysbiosis may contribute to symptoms of depression, anxiety, and other mood disorders. Cognitive function. Emerging evidence suggests that the gut microbiota can influence cognitive function and may play a role in conditions such as Alzheimer's disease and Parkinson's disease. Disruption of the gut microbiota by antibiotics could potentially exacerbate cognitive decline in susceptible individuals. Neurotransmitter production. The gut microbiota produces neurotransmitters and other signaling molecules that can directly influence brain function. Antibiotic-induced alterations in the gut microbiota may disrupt the production of these molecules, affecting neurotransmitter levels and neuronal signaling. Neuroinflammation. Dysbiosis of the gut microbiota has been implicated in the development of neuroinflammation, a common feature of many neurological disorders. Antibiotic-induced changes in the gut microbiota may contribute to neuroinflammatory processes, further impacting brain health. In summary, antibiotics can have significant effects on both the gut microbiota and the gut-brain axis. While these medications are essential for treating bacterial infections, their use should be judicious to minimize disruption to the delicate balance of microbial communities in the gut. Strategies such as probiotic supplementation, dietary modifications, and targeted antibiotic therapies may help mitigate the adverse effects of antibiotics on the gut microbiota and support overall gut and brain health. If you found value in this video, please give it a thumbs up, like, and subscribe to support this channel. Please share across social media platforms to reach a wider audience. Let's delve into more specific examples and case studies to highlight the impact of the gut-brain connection on physical and mental health. 1. Depression and gut microbiota. Research has increasingly linked alterations in the gut microbiota to mood disorders such as depression. For example, a study published in Nature Microbiology in 2019 found that individuals with depression exhibited differences in their gut microbiota composition compared to healthy controls. Specifically, they had lower levels of certain bacterial species, including Faecalibacterium and Coprococcus, which are associated with anti-inflammatory properties. This suggests that dysbiosis of the gut microbiota may contribute to the development or exacerbation of depression. 2. Stress and gut permeability. Chronic stress can disrupt the integrity of the intestinal barrier, leading to increased gut permeability, also known as leaky gut. A study published in Psychoneuroendocrinology in 2020 investigated the effects of stress on gut permeability in rats. The researchers found that exposure to chronic stressors led to alterations in gut barrier function, allowing harmful substances to leak into the bloodstream. This process can trigger immune responses and inflammation, which have been implicated in the pathophysiology of mood disorders and cognitive impairment. 3. Antibiotics and cognitive function. Antibiotic use during early childhood has been associated with an increased risk of neurodevelopmental disorders, including autism spectrum disorder, ASD. A longitudinal study published in JAMA Pediatrics in 2019 followed a cohort of children from birth to age 7, and found that exposure to antibiotics in the first year of life was associated with a higher risk of ASD diagnosis later in childhood. While the exact mechanisms underlying this association remain unclear, it is hypothesized that alterations in the gut microbiota and subsequent dysregulation of the gut-brain axis may play a role in the development of neurodevelopmental disorders. 4. Probiotics and anxiety. Probiotics, which are beneficial bacteria that can help restore balance to the gut microbiota, have shown promise in alleviating symptoms of anxiety. A randomized controlled trial published in Gut Microbes in 2021 investigated the effects of a multi-strain probiotic supplement on anxiety symptoms in adults with irritable bowel syndrome, IBS. The researchers found that participants who received the probiotic supplement experienced significant reductions in anxiety scores compared to those who received a placebo. This suggests that modulating the gut microbiota through probiotic supplementation may have beneficial effects on mental health outcomes. These examples underscore the intricate interplay between the gut and the brain, and highlight the far-reaching implications of disruptions in the gut-brain axis for physical and mental health. By understanding these connections, researchers and healthcare professionals can develop targeted interventions to support gut and brain health and improve overall well-being. Here are some practical tips and advice for supporting a healthy gut-brain axis in your daily life. 1. Eat a balanced diet. Incorporate plenty of fiber-rich foods such as fruits, vegetables, whole grains, and legumes. Fiber nourishes beneficial bacteria in the gut and promotes regular bowel movements. Include fermented foods in your diet, such as yogurt, kefir, sauerkraut, kimchi, and kombucha. These foods contain probiotics, which help maintain a healthy balance of gut bacteria. Limit intake of processed foods, refined sugars, and artificial additives, which can disrupt the gut microbiota and contribute to inflammation. 2. Stay hydrated. Drink plenty of water throughout the day to support optimal digestion and nutrient absorption. Aim for at least 8 glasses of water per day, or more if you're physically active or in a hot climate. 3. Manage stress. Practice stress reduction techniques such as mindfulness meditation, deep breathing exercises, yoga, or Tai Chi. These practices can help calm the nervous system and reduce the impact of stress on the gut. Engage in regular physical activity, which has been shown to reduce stress and promote overall well-being. Aim for at least 30 minutes of moderate intensity exercise most days of the week. 4. Get adequate sleep. Prioritize getting 7 to 9 hours of quality sleep each night. Poor sleep can disrupt the gut microbiota and increase stress hormones, negatively impacting the gut-brain axis. Establish a relaxing bedtime routine and create a sleep-friendly environment by minimizing noise, light, and electronic distractions. 5. Limit alcohol and caffeine. Limit consumption of alcohol and caffeine, as these substances can irritate the gastrointestinal tract and disrupt sleep patterns. Opt for herbal teas or water as alternative beverages. 6. Practice mindful eating. Take time to savor and enjoy your meals, paying attention to the flavors, textures, and sensations of eating. Avoid distractions such as screens or multitasking while eating, as this can interfere with digestion. Chew your food thoroughly and eat at a relaxed pace to aid digestion and promote feelings of satiety. 7. Consider probiotic supplements. If you have experienced disruptions in gut health due to factors such as antibiotic use or gastrointestinal issues, consider taking a high-quality probiotic supplement under the guidance of a healthcare professional. Look for probiotic supplements that contain a variety of bacterial strains, including Lactobacillus and Bifidobacterium species, and follow the recommended dosage instructions. By incorporating these tips into your daily routine, you can support a healthy gut-brain axis and promote overall well-being. Remember that small changes can have a big impact over time, so prioritize consistency and listen to your body's cues for optimal health. If you enjoy this video, please give it a thumbs up, like, and subscribe to our channel for more self-improvement videos. Please feel free to comment below to tell us how useful you found this video. Remember to share on various social media platforms to reach a wider audience. Click the notification bell to get notified anytime we post a new video. Thanks for watching, see you in the next video.